So now seriously, what is Stagefright? Stagefright is an audio and all media parsing and processing library. But it's also a bug discovered by Josh Drake, which is called after lib Stagefright, the library. It's discovered in July of 2015. So how does it work? Let's say you receive a Hangouts message. This message has some media in it, and because Hangouts is gentle, it automatically parses all media for metadata without even watching it. Stuff like subtitles. In this case, the subtitles will be in the TX3G format. This is the code that parses the subtitles. Don't worry, you don't need to completely understand it, we'll just highlight a few lines which are relevant. So the most relevant is this one. Here we'll collect all of the time chunks, basically the parts of the TX3G, into one buffer, one long array basically. So if the size, which is a metadata part of the TX3G format, is bigger than 0, then we'll create a new part of the heap, and then we'll throw up our buffer and the data and just put it all in the heap of a specified size, which is in the metadata. But what is a heap again? A heap is basically a bunch of data which is in no specific order. This is in contrast to a stack which has an order. Use malloc, which stands for memory allocation, on Linux and Android for this, because it's based on Linux. It's dynamic, which means that it will live until you explicitly free that memory spot. What's a heap overflow then? That basically happens when the pointer to a certain piece of memory doesn't exist anymore, but it's still in the heap. That way, data could be corrupted, but more dangerously, remote code could be executed. So, how can we execute remote code? Let's look again at this piece of code. If we see here, we'll check if the metadata of the subtitle file is bigger than 0. So let's say we'll have a subtitle file which starts fairly normal, with one regular chunk, and then after that we'll have some exploitation code. How do we get that inside the memory? Well, we do it by messing with the size metadata. So this command will result in size bytes from data to be written into the buffer, regardless of the buffer's actual allocated size. So this means that we can put more into the buffer than actually needed. This could be other code that will break the whole system. So where can we see these problems? This can be exploited via MMS, so videos inside a text message basically. More interestingly, in web video, because this also can have some videos, and also here we need to parse all the subtitles before showing it. Dangerously, also free Wi-Fi networks. These can have an interstitial which contains a video. You don't even need to see it, it just has to be loaded on the sign-up page, and then basically you're exploited. There's also a dangerous one, ads. Ads can also contain video via a script injected or via an iframe, and then as soon as it's on the page, before even loading it completely or doing anything with it, you're attacked. So how do you protect yourself from Stagefright? The answer used to be Android 5.1, but it's not really a good answer anymore, because in July of this year there were other exploits found, and these were also fixed, but now at a different way, by completely rewriting lib Stagefright. So the only way you can really be sure that you're not affected is using Android 7. Let's thank some people first. So most importantly, Josh Drake, who first found Stagefright in July of 2015, and some people who helped me making this presentation. Thanks for listening.